So good evening and welcome to the 18th Big Data London meetup. I'm personally very excited to see such an audience tonight, and a lot of congratulations goes to News International and all the people involved in this organization. So my name is Manu Marshall. I'm the organizer of this meetup. I also have a daytime job at a company called Akunu, which does big data. So besides being a host, I also do a little bit of big data. If you want to reach me, Manu Marshall. Most importantly, if you want to tweet about the meetup tonight, please use the handle at the bottom, Big Data London. So tonight wouldn't be possible with a lot of companies who've been involved in helping organize this and providing great speakers. So I'd like a big round of applause to all of these. Before you say clap, clap. Let me give you a quick 5-second pitch of each of these. So Akunu, at the intersection of big data and real-time analytics. Elasticsearch, open source search project. We're going to have a talk tonight, so you're going to learn more about it. News International, not to be introduced. Fantastic host tonight. Thank you very much. Music Metric, if you're involved in music and you want to know what your audience think about you, they're the company to check. Music Metric is also one of the organizers of the meetup. Neo Technology are involved in the NoSQL space, and tonight we have them as part of the NoSQL track that we've organized for the last couple of meetups, and they're going to tell us about graph database. And finally, SkyTree, Paul Salazar, straight from the US, will tell us about what they've been doing with machine learning for big data. So now it's the round of applause. Quick word about the community. Great metric. I like round numbers, and we're now more than 2,000 people. So congratulations to all of you. You've made it happen. I think it's really exciting for a number of reasons. One is we're the biggest business big data focused community in Europe, and that's not a small feat. London is absolutely on the big data map. You can see now that a lot of the US marketing organizations are using London as the head start for conquering Europe. You can also see that there's a lot of upcoming conference. You might have heard of GigaOM or O'Reilly, who are now doing their conference in London. And that's all due to the kind of community we've built here. So congratulations. Quick word about, a lot of people ask, where can I reach the community? We've set up 2 spaces. One is on Meetup. On Meetup, you can absolutely see all the members and all the people who are attending the meetups. You can also go on LinkedIn and join the LinkedIn group, where you have the ability to post about jobs or things you want to talk about or discuss. LinkedIn is more suited for this kind of interaction. And lastly, we're going to launch the bigdatalondon.org website, which will be a space where we're going to persist all the great presentations that we've had over time, and we're also going to start blogging about the events. So if you're interested in contributing to this community website, please contact me. Now we got a packed agenda of great speakers, and we're going to start with News International, Ian MacDonald. So please join us. Okay. Welcome, Ian.
Thank you very much for coming along. It's a pleasure to have you here. Ian MacDonald, the Director of Engineering here. Now, ignore this tweet hashtag here. We're going to use Big Data London, as I've seen on the first slide, so we didn't quite join up there, but Big Data London is the hashtag. Now, I'm only going to do an introduction because I don't want to get in the way of the good speakers that we have here tonight. So, first of all, who are we? You probably know us for the Sunday Times, the Times, the Sun, but we've got a number of other brands and brand extensions as well. Fabulous Bingo, the Times Literary Supplement, Sunday Times Travel, the Whiskey Club, Milk Round, which is graduate recruitment, Sunday Times Driving, Sunday Times Wine Club, and Sun Bingo. So we've got a whole range of brands here, and we're part of the News Corporation empire. Okay, so a couple of quick housekeeping things. If you want to get on the wireless network, the SSID is GuestNet. Now the password is Guest Wireless, all one word joined together. So Guest Wireless is the password for that. Goes straight out onto the internet, totally unrestricted. And I'd also like to draw your attention to the things we've had handed out. You can get the times for £2 a week on the tablet, as well with the sign up URL there that's on the cards that you've also got there. Well worth having a look at for £2 a week. So we've got to sponsor the event, so I'll give a bit of a plug on that. We're looking for people as well. So we've got about 400 people in the tech organisation. We're a large tech organisation. We're very cloud focused, big data focused. We're very looking at very much at futures. We've got 600 servers now running on Amazon. We're running all our email and collaboration on Google. So we're very forward thinking, and we've been doing that for the last couple of years. So we are a technology company at heart now. Rupert downwards has realised that we are transforming into a digital industry, and we're being driven in that way and invested in that way. So we've got a number of roles. We've got a tech lead for the big data project that we've got going on, and this is and it's not just for big data here in the UK, it's tech lead for our big data project worldwide for News Corporation. So quite a thing to have on your CV. We've got a range of things also, such as Scrum Master, Amazon Systems Engineers, and we've got a whole range of development and test opportunities as well. So you can have a look at the joinnitech.co.uk website, and you'll find that you've got that on some cards that you've been handed out as well. If you want to follow us on Twitter, you can follow us on Twitter at tech@ni. And if you want to know more about us, or talk to us about jobs, etc., talk to the staff members around. We've got badges that sort of look like this. We'll sort of be around at the end. And that is it for me. I want to hand over to Mike now to talk about that.
My name is Mike Keating. I'm the product owner of the big data platform at News International and News Corp. This evening I'm going to give you an overview of some of the things we do. I'm going to talk about where we started, why does News International do big data, what's the fit. So I'll give you some examples of things we do, the data we work with, the decisions we make and what we're trying to do there. I'll talk through some of our technology choices, from the tech itself to why we chose that and who's involved in that. And then I'll wrap up with some of the lessons that we've learned over the last year. So my role is product owner. That means that I kind of sit across the platform as a whole. I've been working here with the team for the last year, and over that year we've kind of built up the team. We've started to expand into new areas and new bits of tech and new bits of product as we try and touch different bits of the business. So a start point is, News International is a big business. It's long established. It's got a wide range of systems. So it's got lots of data, it's got lots of suppliers, it's got lots of technology, and it's got lots of teams. As Ian said, we've got 400 people or so in the tech organisation, and we've got similar sized marketing and sales and subscription operations. So all of those teams are generating data, and what we wanted to do was take a different approach to what we'd done before. And so the big data platform team works as a startup within News International. It's a small team, very focused on what we might be able to do with data. So our first step was take control, kind of bring digital data into one place and then see what we could do with it. How could we link it up? How could we look for new approaches that we haven't covered before in our traditional systems? And well, that's a very tech approach. What we're really trying to do is get business value from that. So we're trying to make data available, information, knowledge, and insights. And you've probably seen that classic triangle where we're trying to work up from data up through to insight, because insight's what's really changed in the business that we work with. And we've got a base point of trying to build awareness and create a decision-making capability amongst our teams. So I'm about to show you a series of slides that cover what we do. You're going to see some numbers. I have to say they are not real numbers. They are illustrative only. So News Corp is about to split into two. We're about to launch the Sun subscriptions business. Certain numbers are very sensitive, and so just to keep a blanket approach, we've taken out most of the key numbers. You'll still get the idea for what we're doing, though. So, this is News TV. News TV is one of a series of dashboards that we operate across News International that try and bring everyone up to a common level of awareness. So what's going on in our titles? And in this view, flossing is a waste of time or money. Get it on the Times, £2 a week. Great story. So unique visitors, page views, time on page. Across the bottom, we've got what was the most popular section yesterday. Popular sections, popular journalists, popular stories. And the aim of News TV and its sister dashboards is to just try and make everybody aware so that when you have a conversation, you know what you're aiming at. You can't say, I'm going to get 1 million extra page views if you don't have 1 million in the first place. So, we produce content. And we produce content in different sections of the paper and across different sections of our websites and apps and mobile apps. So we really want to move beyond a world where we think about visitors and visits and page views, because they're great stats, they're big numbers. What we're really trying to understand is, are people engaged with our products? And so in this example, what we're looking at on the y-axis is how many views per visit, and on the x-axis, how many visits per visitor. So the higher you are, the more you're doing on the site. The more to the right you are, the more frequently you're visiting the site. I'm sure you really want to know which one of these is page 3. I'm not going to tell you. Suffice to say, that's the kind of thing we're trying to establish. Which sections are really popular? Which sections are hit or miss? Some sections, this graph is completely different because they have great days. And so we're trying to make that available. What do we do with it? It's kind of an FYI. So we work with the business teams, we work with the editorial teams, and we're saying, look, this is the kind of thing that's going on the site. Maybe it's different from one app to another. The tech that underpins this, it's R. So it's a graph that was produced in R. The data that drove that was pulled through Hive, and that was coming off our Hadoop cluster, and a pipeline had got us to that point where we could pull it from Hive. So obviously people are on our site, and we're thinking about engagement. And one of the great measures of engagement is, do you share? So do you tell your friends what's going on the site? So this is our social dashboard. We're looking at things that are being tweeted, things that are being shared through Facebook, things that are being generally distributed amongst your friends as a measure of engagement. And so in this example, we're checking out which articles are being tweeted. David Moyes and Alex Ferguson, big article, went on and on and on. And we're checking out tweets, we're checking out retweets. And you can see the Times have won that day. So we like to engender a good sense of competition between the Times and the Sun. The Sun like to be on top, obviously. And so we're checking out that. And this updates in real time. It updates each day so that you can see what's working well. So moving on from content, we are a subscription business, £2 a week, remember. So what we try to do is we try to understand product growth. So we've got lots and lots of subscription products, from the offer Ian talked about through to the standard offers that you'd see every day. We've got lots of products that have different attributes, different tweaks. It might be pricing, it might be contract length, it might be access to different apps. And we're trying to understand which things give you a good product. Good means one that sells well, one that keeps its customers. So in this example, we've got a range of products. We're checking out which ones are working. You can see there's a real variety. It doesn't mean, by the way, that the one at the top is far better than the ones at the bottom. It just means that different effort, different spend went into those. We're trying to understand the things that work. Again, technically, it's R pulling data from Hive that went through the pipeline. But it's also being matched up with different data sets. For example, the Excel spreadsheets and the SAP feeds that manage our products. Okay, so with any subscription business, there's also the problem of churn. So subscribers join us, subscribers leave us. Lots of things affect churn. I'd really like to say, here's a list of them. That might be breaking too many secrets, but one of the things that we're doing is trying to track that. So in the chart you see here, what we're looking at is a series of decay curves, and they're decay curves that are plotted for a lot of the attributes that we deal with. And obviously we'd like a nice flat line, because that would mean no one dropped out. This line at the bottom in blue isn't so great. But we're trying to find the things that affect churn so that we can deal with them as we roll that back into the subscription product design. We also build products. So Ian's team are there. They're building the website, smartphone apps, tablet apps, and we've got some really interesting ideas. So news is an ancient business. From the first time papers were printed through to today where you're consuming apps, you're consuming content on your phone. But there are very defined habits about how you consume content. And the device you use, the app you use really impacts that. So everyone knows how to read a paper. You open it, you turn page to page. So our iPad apps have a very similar feel. They're in the bottom right, and it's called a linear edition. You start on the home page, you scroll through, you scroll through, you scroll through. Eventually you'll reach a point where you'll jump. And so this linear edition flow is something we see, and we try and understand how people behave there. In the middle, we've got websites. So our website is very homepage oriented, it's very section page oriented. People jump back and forth. That gives us ideas on how we might change navigation, improve navigation, try and move people through similar flows. And my favorite is the octopus. So our mobile app navigation is very section oriented. You drop into a section, you scroll through 3 or 4 articles, and then you jump back to the next section. And as we see these things, they reinforce some things we think, and they help us discover some new things about how people behave as they use our sites. Okay, so again, really interestingly on this one, the tech is a little bit different now. The tech, so this is a D3 application. It's the D3 force-directed nodes. It's building from data that was pushed through our pipeline, and that's a Hadoop-based pipeline, which I'll come on to next. So all of those products are things that we build within the team. We're building them on a real range of technology. So we'll start with a list. I'm not, fortunately for you, going to talk about all of them. I'm going to talk about some of the key ones that we really have made a big win from. So as Ian mentioned, we are a big cloud shop. We're using Amazon, and Amazon is the hosting base for our platform. Operations, we've got lots of systems. I think Jenkins is a big win. Continuous integration and execution of jobs, it's really worked well for us. Puppet, big win again. Automated configuration, deployment of that as we run different jobs. Updating packages, really a lifesaver for us at times. Java and Python, Java MapReduce. So you've got to make choices, which I'll come on to in a minute, and Java MapReduce was a great one for us. We've now evolved that into using Apache Crunch. Apache Crunch is an abstraction layer on top of MapReduce. It makes writing jobs much, much easier. So if you're in the business of writing Hadoop jobs day to day, you might have used Scalding, but Apache Crunch could be a good fit for you. Celery. Celery fits into our real-time pipeline. It drives the social dashboard. It's a queuing and task management worker system. That's really powerful for us. Data storage, no real surprises there. We are a Hadoop platform. We use HDFS intensively. We've got HBase as our database, but we also use S3 as a persistent archive that doesn't have to, for data that doesn't have to be on HDFS. So HDFS is for working, S3 is for persistent storage. Avro. So who's heard of Avro? Cool. Who wants to tell me what it is? Okay, so Avro is great. It's a serialization format. It allows you to store your schema with your data, which is important for versioning and tracking changes in schemas over time. It allows read schemas, it allows write schemas. So that's great. It is very tedious to work with. So when we have a really bad day, we give someone an Avro file and tell them to work with it. When we have a really good day, we take them through that, because once you're there and using it, it's powerful. But there's a definite knowledge step to try and use it in the first place. Data access, all kind of standard stuff. Analysis, I kind of call that out. So it's the analyst's choice. So lots of you will work with analysts, and they'll come and say, I'm an expert in R or Excel. I'm an expert in Excel. Brilliant. IBM modeler. And you go, okay, well, how does that work with these different things? So we try and separate these things out so that people can use the tool they want to. We make data available to download. we try and set up so that you can use the tool that's most comfortable for you. Visualization, R, D3, pie charts and Google Charts, great products for us. And our products are built around APIs, JavaScript, HTML, and CSS. If you've got any questions, then we'll go through that in a few minutes. So one of the questions I got in advance was, why did you use those things? So the number one consideration in any technology choices that we've made is team. So you've got to build on your team's skill sets and knowledge, because otherwise they have absolutely no way to jump into this stuff. So Java MapReduce is a great basis to start. There are a lot of Java developers. We've got some great Java developers, and we've got some great Hadoop developers, and we've had a great fit there. As we've tried to hire, recruitment, hireability, I've invented a new word there, has been really important. So being able to hire people with the right skills is really important, because it's a packed market. I'm sure there's some recruiters here who could tell us just how hard it is. Open source. So open source is a huge win. We've had great wins from it. There's really great communities around products, and we've been able to contribute back in some cases as well, and that's a big important thing for us to do. Open source introduces the idea of versions, though, as people make massive changes between different versions. So we try and focus on using what works. We've got alpha releases. We try and be really savvy about alpha releases. Sometimes we use them. You never use them as production code, else you get burnt. Consistency. So as Ian said, we use AWS. So we kept on using AWS. We've got a skill set in-house. We want to build on that rather than jump to something new. And flexibility. So use the better product where it makes sense. So we've tried lots and lots of things. And sometimes we've been embedded in a particular way of doing things, but we've found a better way. We've been quite conscious but brave about making some choices to stop what we're doing and move on. Okay, so who does all this work? We've got a tech lead, architecture, design, hands-on development, and that's a role that we're recruiting for at the moment. We've got delivery management, so project management with an agile flavor, but probably not an agile guru. Got a team of Hadoop developers who build on Java MapReduce using Crunch and some of the tech I talked about. Got a series of Python guys doing a great job with both Python and UIs. Tornado and native Python are big things for us. Data science, using Hive to access data, using R to process data and analyze data. And we've got some modeling work, but that's probably a big focus for us for the future. DevOps, AWS, Vagrant, Puppet, those things that really shape our world. And I've also been asked to talk about why we hire in these skill sets and what kind of thing we're looking for. So they're really important for us because they're a good technology fit and they're a good team fit for news. As we look to bring new people in, we're really looking for people with practical experience of Hadoop in production. Those last two words are critical. So you know what you're doing when you rock up. It's really expensive otherwise. Now, there's a qualifier there. Not everybody is the most amazing Hadoop engineer ever with years of experience. And so the other thing that works for us is capability. You've got the capability to learn new technology, to design it and build it. So you're probably a good engineer. You've probably got experience in other areas. You know how to learn quickly. Those are good things for us. And one of the things that really shows that is demos. So when you roll up to an interview, it's brilliant if you come in with a coding sample. I don't want to see the work from your previous job. I appreciate that's completely confidential for you. But something you've contributed to an open source project, something you've made as a demo, because it gives us a basis to talk about things. And so just to wrap up, some lessons we've learned. So as you start on your big data project, building awareness and common knowledge is really important. You've got to build on your existing teams, the existing systems and their work. We're looking to add something extra. So we're not looking to replicate work that people already do, because otherwise you don't get the benefit from it. Visuals are really important. The news TV is beautiful. It's beautiful so it engages you. And that visual aspect is super important for people. We've worked with a range of teams to share those outputs, and we found that visual is good, but really working in a detailed way with different teams works well. And hopefully we've made some good tech choices. Sure, that'll pan out. So I don't get to do this very often, so I wanted to say thank you to some of the people we work with. So our big data team are DevOps guys, Hadoop guys, UI guys, analysts and testers. So they've made a massive contribution to us over the last year. We've worked with a real range of technology teams, from the design guys, production ops, performance testing, security, products, platforms, and service tests. They shape your big data platform. It's not 5 of you sitting in a corner knocking stuff out. In a big organization, that's what makes it work. And we work with editorial, marketing, commercial, and finance teams, and great people in there have shaped our project. So thanks very much. Hope you found that useful and interesting. I think, Manu, we're going to do some questions. If you want to get in touch with me, I'm Mike R. Keating. NI Technology is tech@ni. And if you want to apply for any of our jobs, then that's the website to hit. So joinnitech.co.uk. That's why I do it. Yeah, so I won work for my free time subscription, but also, you know, NI is a great place to work. Building a startup with NI has been really cool. So it's a source of funds, but it's also a source of opportunity and real data sets that you wouldn't otherwise access, probably.
One of the things you haven't mentioned around the things you're building is the guys you make revenue from, like the advertisers. How does the old advertising when you're planning and being really kind of buying agencies on behalf of brands work with you to obviously get you guys more revenue? How does that embed into what you're doing?
So that's on our to-do list, essentially. So advertising is a big, complex field. There's lots of, I guess some of you, in fact, probably work for big data advertising companies. And we meet a range of vendors with different and interesting solutions. We've prioritized our list, and because we've got some good stuff going on, but advertising is a big to-do for us.
So I was talking about how you work with the agencies, because obviously they're interested in, they work with you on a day-to-day basis. How do you use your analytics to help them advertise to the right people?
So as I said, advertising is a to-do for my team. The commercial sales team who deal with the agencies on a day-to-day basis, they take some of our outputs, they take some of the existing outputs from the different news systems, and they have a very dynamic conversation with agencies and advertisers based on what do you want, what's the audience and the product that we've got available, and how do those things fit up. So, sorry, the gentleman at the back, and then.
Yeah, you mentioned what the scale of the data is today. What scale of data are you handling in the cluster, and then as you bring data out, what sort of scale of data are you handling today?
Okay, so we probably deal with 20 to 30 core data sources. The bigger of those are things like our clickstream logs, where we're dealing with hundreds of millions of rows a day across an app, and we've got multiple apps. So in data size terms, we're probably talking from a couple of apps, so are 20 gig per hour, and so multiply that out. So reasonably big data sets. Once it comes through, we output data in different sizes, so different people want to work with different sizes. So some of it goes straight out as raw but clean, and others aggregated into something that you could work with in R or Excel fairly easily.
How are you measured, and has that changed, or do you see that changing?
I think it will change. So we've been fortunate to work up in a startup environment within news, trying to build out the platform and see where we get to and what we can do. So probably our status today is we've got some really good stuff that we think fits well, and we've had good conversations with our business teams. Obviously, you've got to make money. So if I go back a few slides, I've got to tell you where subscription works and doesn't. And that, the delivery that we change is how we will measure ourselves.
Thank you. How are your editorial teams at taking input on adjusting content based on the data you provide them?
That's a good question, and one I think I'm not going to answer.
What have you transitioned from to this new
new platform?
So we've largely avoided transitioning. So the question was, what have we transitioned from to this new platform? We tried not to duplicate. We tried to look for the gaps. So two years ago, you couldn't process a 200, 500 million row file. Hadoop setup has allowed us to do that. And so we tried to go for the extra things. So previously we would have used Google Analytics or Omniture or Web Trends or their sisters to get aggregate stats. Now we can look at a deeper level. So not too much transition. Okay, great. Thanks very much, everyone.
Michael, thank you very much. So next, well, thank you very much, Michael and Ian. Next, we're going to have go on with our NoSQL track. So for the last couple of meetups, we've been exploring various technology that are tagged NoSQL or not only SQL. Is anyone not familiar with NoSQL? Raise your arm. Good. This is a big data meetup after all. So this time we're going to explore what happens in the world of graphs. So, Rick?
Yep. All right, guys. Thanks for having us, Manu. Really appreciate the invitation. Going to talk a little bit about something a little bit different from what you usually get at big data groups. Actually, when we were discussing this beforehand, I actually wanted to call it the small data talk, because at the end of the day, we're not really talking about volume in this talk. Right? So we are going to talk about how do we get our data, I need to stand in front of this mic, right? So how do we get our data across the barbed wire? How do we get something from the data that is meaningful, that is insightful, that allows us to make better decisions, right? Not just by crunching the data, but by dealing with both of the problems that we find on the relational crossroads. I don't know where Alistair is. Alistair is my colleague with the fancy blue shirt. He's right there. If later on you need some technical answers, he's the guy to talk to. Obviously, you can talk to me as well. But he actually created a version of this relational crossroads. The relational crossroads is the point where you start hitting a brick wall when you're dealing with relational databases. Right? And that brick wall can take multiple faces. Right? They get multiple shapes. One shape is, how do I deal with volume? But another shape is, how do I deal with complexity? Right? So we'll talk a little bit about both here, right? Because dealing with volume, to me, that's dealing with the big data problem. Right? Dealing with complexity is to deal with the big data problem. Right? They're different things. Right? Let's get that straight. They're related, obviously, because NoSQL has given us this new set of technologies that can address both of those problems. Right? And when we talk about Hadoop and Hive and Pig and all those wonderful things, we're mostly talking about dealing with the volume problem. Right? How do we get access to those 300 million rows of clickstream data? How do we analyze that? How do we process that? We couldn't do that before. Why? Because the relational databases, as the data sets get larger, they start failing. Right? They start, going off a cliff. They don't work anymore. Right? That's why the NoSQL movement has invented key value stores. That's why we've got column family stores. That's why we have document databases. Right? Right, so we have these new technologies which I don't want to discard at all, right, because they're wonderfully valuable, right, but they deal with one side of the relational crossroads, which is the volume problem. And guess what? I want to talk about the other side, because at the end of the day, you're talking about volume, you're talking about large amounts of fairly simple data, and I want to talk about something else, which is how do you exploit that data? How do you deal with the complexity that comes from all of that data? How do you make something out of it that actually provides insight and better decisions? Right? The big data problem, right, as I'd like to call it. Right? So the big data problem is all about complexity, about dealing with complexity. I need to stop looking around. Yeah? Complexity for us is a function of three important factors. Yes, size is an important factor, but other things really matter as well. Connectedness and variability are probably the two most important ones. And this is something that brings us to the world of graphs, right? Because this beautiful Swiss mathematician actually was one of the first people, 250 years ago, to deal with complexity in a completely new way. He had to solve something that is known as the 7 bridges of Königsberg problem. Anyone remember that from their math classes? Yeah, 7 bridges, right? Emperor of Prussia wants to visit Königsberg, and as an emperor does, he has some demands. I want to eat some food, I want to meet some people, and I want to see the city, right? I want to see the city, and I don't want to walk a single street twice. So no one's able to figure this out. So they call up Switzerland, right? And they ask Euler, help us out here, right? And Euler, the first thing he does is, let's forget about the streets. Let's not worry about the streets. This is a medieval city, there's enough streets, little alleyways, all those wonderful things, right? We don't need to worry about the streets. The only thing we really need to worry about is the bridges that connect the different parts of the city, right? That was a fantastic innovation, right? He actually took a step back and said, let's forget about all of those things. He put a layer of abstraction on top of it, right? The second thing he does is he basically says, I need to apply a mathematical algorithm in order to figure out if this thing is possible, yes or no. And he came up with this wonderfully complex algorithm, also known as counting. Right? He started to count the numbers of paths between the different parts of the city. And he realized that, the first part of the city that he leaves, right, he's going to walk off of. The last one he's going to walk onto, but every other part he has to walk onto and off of. Right? So he counts the numbers of edges, figures out that they're all uneven. Every part of the city has an uneven number of edges, and he realizes it can't be done. So he calls back to Königsberg and says, can't be done. Very simple. Right? That's what he did, right? He creates this abstraction, right, on top of a really complicated problem and applies an algorithm, counting. And that's what we do with graphs all the time, right? Why? Because they are so wonderfully simple. Right? When you start designing software applications, how many times have you walked up to a whiteboard and drawn the domain? You can tell I'm Belgian, right? You draw the domain. You draw how things connect to each other. Right? And that's exactly what you will do when you start working with graphs and graph databases. Another great example is this thing. You recognize this, right? The tube map, right? The wonderful thing about the tube map is that my grandmother understands it. Right? She understands how to get from London City Airport to, Southwark, where our office is. It's very intuitive. It's an intuitive way of dealing with complex data structures. Right? And I'll show you some of that afterwards. Neo Technology has built this database, which is not about volume, which is about complexity, that deals with what we call property graphs. Property graphs are structures of data that allow you to store your data in nodes, multiple nodes, and relationships between them, connections between nodes, and properties on both. Right? It allows you to look at the data in a completely different way. They're not no long lists of keys and values. They're not tables and records and columns. They're nodes. They're a network. You look at your data as a network. Right? I was actually looking at one of the slides of the previous speaker, the click-stream analysis. That looked very much like a network, right? If I had that right. Right? So you store it as a property graph, and you start exploiting that data by querying it, by walking across that network. You walk across the network and you figure out what's going on in that network. Neo uses a specific query language to do that. It's a graph query language called Cypher. And you'll learn more about it. It's a little bit like SQL, right? But it's specifically designed to deal with these network structures, to look for patterns, right? To look for paths, to make complex questions that take multiple hops. Anyone heard about Facebook graph search? Right? That type of stuff. You know, I want to find myself a restaurant in London that is serving Indian food, is open on Sunday and caters for kids. And my friends have liked it. Right? That's the type of question that you want to be asking. Lots of join operations. Does that make sense? Lots of hops on the network. There's a reason why Facebook called it a graph. Right? So we do that with using Cypher, which is a pattern matching language, as you will see right now. Because I want to actually spend a little bit of time, I want to show you a little demo. Because I'm from Belgium, right? And as you can see by the Stella Artois that you can get in the back, you know, we make great beer, right? We make a lot of beer, right? And actually, when I started working for Neo, they gave me a database that I had zero affinity with, which was the Doctor Who database. I never watched Doctor Who, I'm sorry, but I do drink beer, right? So I actually created a beer database, right? And you can download this and you can look at this afterwards if you want to. Is this visible at all? I can make it a bit bigger. Yeah. This is my beer graph database. And I want to show it to you because, for me, a beer lover from Belgium, right? You putting stuff into a beer graph yielded some fantastic insights, new insights. So let me clear this up and start over, right? What you see here is Orval. I don't know if you know Orval by any chance. It's a Trappist beer brewed in the Belgian Ardennes, close to the border of France. It's a fantastic beer. I can highly recommend it. I've actually drunk it here in London. It's a fantastic beer. It's a Trappist beer, right? It's got 6.2% alcohol, right? It's brewed by this particular abbey, right? And all of a sudden, this was a big revelation for me. There's this new bulb coming up. Can you read it? I don't think you can. It's a Trappist beer of 6.2% alcohol that I had never heard about. Just by visually exploring the network of beers that I had created, right? I bump into this Trappist beer that I've never drunk before. And to be honest, it was like a thunderstruck for me. So I start looking around, you know, where can I find this beer? Turns out the price is really high because it's the beer that the monks drink. And I'm not doing that anytime soon. So this was like a revelation, you know, visually exploring this network of data, right? And obviously, this applies not only to beer, right? You can do it with any kind of data. But visually exploring this was like immediately yielding powerful results, right? Let me show you another example here. Graphs, like Euler already demonstrated, are fantastic for finding paths. Right? You've got two pieces of data in your data set, and you want to find out how are they related? How are they connected to each other? Right? That's what Euler did, right? He wanted to find a path, right? Finding a path was the second revelation that I had with this beer data set. Right? Two beers that I really like, right? Duvel and Orval, right? And I wanted to find out how are they related? Are there things in common? What's on the path between those two beers, right? And I found these two beers. You know, you probably never have heard of them. I had never heard of them. Wilderen Goud and Hexamie beer. And they are new things that I would love to try because they're high yeast beers, something that I like. Duvel is a high yeast beer. And they are 6.2%, which is the same percentage as Orval. So without knowing my data, by applying this algorithm, this path-finding algorithm, I found out another revelation. You know, there's these two beers I really want to taste, you know. Really interesting stuff, pathfinding, exploring your data visually. Fantastic stuff. This is actually my beer graph model. You can take a look at it afterwards if you wanted to. There's lots of variations of it. You can actually make this more complicated as you want. Won't go into that. But I hope to have made it clear to you that, you know, these types of new data representations, you know, network-oriented data representations, they may not deal with the volume problem as nicely, but they can deal with the complexity problem in a beautiful way. Beer insights was my big revelation. Right? I found new, beautiful beers that I'd love to taste without becoming a monk. Right? So that's about it from me. Thank you very much. I hope this was useful. And if you want to learn more about this stuff, talk to myself, talk to Alistair in the back a little bit later. We'll be here all night. So thank you very much.
Thank you, Rick.
Yeah, questions, yeah.
Couple of questions, yeah?
A quick question.
Yep.
Sorry, there you go. A quick question. You said you can't actually scale it that big. How I see this is a metrics operation. Why can't you scale it?
So the scalability problem, and he knows that much better than I do, but the horizontal scalability is complicated for us, right? Distributing a graph across a large number of machines, that's the thing that really drags it down a little bit, right? And we're working on solutions. Actually, Alistair is part of a team that is actually developing this. But distributed graph processing is one of the most complex computer science topics that you can imagine. And that's what's currently, in the current Neo4j product, for example, that's what's missing right now. But other than that, it scales very well horizontally, right? So there's also, well, there's lots of stuff that we can talk about there. Anyone else?
How about the velocity of the data?
Excuse me, sir?
How do you deal with the velocity of the data?
Yep. How about the velocity of the data? I mean, what you...
How do you deal with it?
You know, changes in the data, right? So graph databases, just like Neo4j is, you know, they are OLTP databases, right? So you can actually do updates on the data as you go along, right? So you can write to them. It doesn't have to be in batch. It can be in the clickstream, and obviously, you know, there's performance implications to writing because it's an ACID database, right? So it's an ACID database, which means, you know, not eventually consistent, it's immediately consistent, right? And that has different performance characteristics, but it's, yeah, for a specific purpose, it can be really, really good.
I don't really care that two beers share the same percentage of alcohol, but I might care that more that, you know, they both come from the same region.
Mm-hmm.
You have a concept of priority in terms of, you know, one particular attribute is more important than another one.
Is there a concept of prioritization of properties, right? Which is essentially what. So I think that's a modeling issue, right? So and one of the things that you will find in graphs is that there's multiple ways to skin the proverbial cat, and you can do this in many different ways. And if that would be important to you, if priorities of properties would be important, then that would probably have a modeling implication, and you would probably structure your data differently in the graph. And then it may also have an algorithm implication, right? Where in the algorithm you actually do some checks before you proceed on the traversal. I think that's a really interesting question, but we should have a Belgian beer afterwards and talk about that. Yes?
What distinguishes your visualization tools from other visualization tools? Are some test relationships and multi-dimensional relationships? Lots of complex trade. So how does your product differentiate itself?
So the visualization that I showed you earlier, it's the simplest of the simple visualization, right? Or visualizations, and there's a lot of other types of visualizations that can fit on top of it. And actually, to be honest, we as a graph database vendor, it's not our job to build visualizations. Right? So you can actually use R or something else to put a visualization on top of it. Right? So I think what it's probably very good at is these network exploration type of visualizations, right? Where you sort of look at the network from 50,000 feet, jump in, right, and start walking. Right? That's what it's really, really good at. I mean, I'm not saying that other stuff can't be done, and then I can show you other examples as well. But the visualization that you saw earlier is just the simplest of the simple ones. Yep. Yeah. Oh, it's not that difficult. Obviously, it depends on the source data, right? But I think related to the other gentleman's question, it really depends on how you would model it, right? Because there's multiple ways of doing it, and depending on how complex the model would become, you would probably have a little bit more effort. But for example, this afternoon, in under an hour, I put in all of the flight networks globally. I found this Excel file that has all of it in it. I spent an hour on it, and it was in the Neo4j database. So it's not difficult at all. If I can do it, you can do it. Right?
I have a question and a comment. The question is, you said that complexity is a function of size, connectedness, and variability.
That's not scientific, right? So.
Talk about variability.
Mm-hmm.
That's the question. The comment is that when you have graphs, you either have a connection between nodes or you don't. But you could imagine having a degree of connectedness, in which case graphs become a subset of basically a similarity metric.
Mm-hmm.
So you could then treat your problems using similarity criteria.
Absolutely, yeah.
So
So.
I'm still interested to see how you do it.
So variability, what I mean with variability is the idea that in a relational database, you often get semi-structure, right? Sparse tables, right? Things like tables with holes in them, null values, right? That's an indication of variability and semi-structure, right? And because a graph database doesn't have that sort of predefined rectangular schema, right? It is better at dealing with that variability, right? That's not a scientific comment; it's an assessment, right? And so that's the answer to your question. And now I've forgotten about your comment. Oh, it was around the weights. Yes. Yep. So that's actually one of the key differences between things like semantic web technologies, RDF stores, triple stores, and property graphs, right? In RDF stores, you have a subject-object predicate that connects them, right? And the predicate doesn't have weights, right? It's a predicate, right? In a property graph, the predicate, or AKA as the relationship, can actually have properties, can have weights, which allows you to do really sophisticated things when you're trying to determine paths. Because you can say, for example, okay, I want to get from London to Leeds, right? I have a train option, I have a flight option, I have a cycling option, I have multiple options, but they have different speeds, different CO2 exhaust, and you can actually take those parameters, those properties, into account as you sort of calculate your optimum path. Right? So that's actually a great use case for a property graph. Does that make sense? Okay, cool. And I think.
One last question.
Yep.
Andrew?
How do you manage versions of properties and of nodes and edges?
That's a modeling question. Because so there is no, at least in Neo4j, there is no like out-of-the-box functionality for that. You can model it in, right? by, for example, using an in-graph index, right, where you connect different versions of your nodes to different points in time. Stuff like that is commonly used, right? But there's no like, I switch this on and you've got a temporal graph or something like that. That's not part of, at least not part of Neo4j. Okay?
Thank you very much.
Thank you. See you guys.
Good evening, everyone. My name is Costin Leau. Great to be here. Excellent location, fabulous view. Such a great host. So I'm an engineer in Elasticsearch. I'm leading the Elasticsearch Hadoop integration. And well, I'm going to give you a 15 high-level quick introduction to Elasticsearch and how you can use it to do search and analytics and a bit of everything in between. So I'm going to talk about Elasticsearch and wrap everything up by demoing Elasticsearch with a simple UI, which we call Kibana. So let's start with search. Term has a broad meaning, means a lot of things to a lot of people, so I will try to very quickly put some light into that. For many people, when they think about search, they think about data retrieval based on some sort of tagging. So you look at information, you basically slice it, put some tags on it, on the information that is highly valuable or relevant to you, and then you start using that to do retrieval. So for example, you say, find me all the banks that have more than X accounts. Obviously, when I'm dealing with banks, I'm dealing with accounts money, so that's relevant to me. But if you change that question a bit, such as find all the banks near me, things become different because so now it's not so much about the banks, but rather about the entity that was a question and its location, right? Or you can even go crazy and ask the ultimate question of life, right? So search is not so much about the data, but actually about the context in which it happens, because the context makes some data relevant and some basically becomes filtered out. So if you have to split out the various things that happen with search, you have, right, the initial data retrieval based on tagging, which pretty much any file store or data store uses. For example, when you're looking for a file or a picture, you use a file name and its path. You're looking for a bank, you potentially use a bank name, user ID, right? But most likely, when you want to look at the data, the entire set of data, you want to use something which is called full text search. So for example, when you look for a sentence in a book, you're not going to use just a table of content, but also the book name, but the actual structure, the actual data within the book. You can add some context or dimension to the search. So you can do things like highlighting, which means not just finding the terms, but actually also the place in the book. You can use geolocation, which means obviously you're considering location. You can do things, well, if you want to use the fancy terminology, you could call it fuzzy search. This is a typical did you mean, right? So when you do a query, you can actually also find the suggestion there. So you're not just looking for exact data, but also the data that resembles the initial data. And then you can do things like natural languages, which means I'm looking at a piece of text or data is gibberish, or maybe it has a different, simple meaning, or if I'm using slang, completely opposite meaning. So, if you break this down, you have basic data retrieval using some sort of identifier or tag, and the more logic, the more data you put into it, the more complicated your searches are, the more you're pushing toward a search engine. Now, when you ask me to, sort of quantify the market, and because search is such a broad term, it's near impossible for me to actually make this work in one slide, so I just tried it to just chop it into some, big buckets out there. So you have the, search engines, web search engines. This is the big players that pretty much everybody knows about. So you have the likes of Google, Yahoo, Baidu. Then you have the enterprise search. This is where you have the big vendors coming in with various offerings from hardware to software suites. So you can have things like CRMs or dedicated search solutions. And then you have the open source space, which actually has been around for quite some time, very active, and in many cases actually at the core of the spaces that I've talked about. So there you have things like Sphinx, Apache Lucene, which is becoming the sort of the de facto toolbox for creating search engines. You have Elasticsearch, which I'm going to talk about, Solar, Sensei, various products out there. So what is Elasticsearch? It's an open source search and analytics engines. It deals with both structured and unstructured data in real time, meaning that most of your queries run really, really fast. We're talking here about milliseconds. It has very powerful analytics capabilities, what we call facets, meaning aggregation. So you can define formulas that get computed in real time. So as you go through the data, you can actually see the results happening, being computed. There's nothing pre-computed there. We don't do any predefined indexing. We literally compute everything on the fly, as you'll see in just a bit. And everything is REST-based. So just like a site is being accessed, can be accessed by pretty much any browser, Elasticsearch can be accessed by any language or platform out there. From the get-go, it was designed to be scalable. So it can run on a PC, or as we have here, on a Raspberry Pi cluster, and this it actually works and can answer queries to clusters that have hundreds of nodes. We have a customer that uses the entire email throughout the company, 2 petabytes of data on a cluster with several hundred nodes. Elasticsearch is very popular. We started doing some tracking, so we have over 200,000 downloads per month, and probably some of that is because we put a lot of emphasis for our users. Whether we're talking about individual developers or small teams to companies, probably company that here you probably interacted with it one way or the other to date. So let's see. Before that, I was just reading on the way here about ThoughtWorks, and I'm glad to say that they just published the Radar technology radar for 2013, and they mentioned Elasticsearch for the first time, and they did that by putting it directly into the adopt quadrant there, citing its versatility, powerful capabilities, and vibrant community. So we're very happy about that. Okay, what are these users using Elasticsearch for? So obviously you can use it to do text search, meaning to actually look at text. GitHub, for example, uses Elasticsearch for the entire website. So anytime you do a query, whether it is for issues, comments, code, lines of code, everything is served in real time by Elasticsearch. In real time, Elasticsearch serves over 1.3 billion files out of 130 billion lines of code. And obviously that's a big number that keeps increasing every day. You can use it to do geolocation. This is exactly what Foursquare is using Elasticsearch. So it's not just about text, but also about, again, that extra dimension that is relevant to your application. In this case, looking at 50 million venues, figure out where they are. You can use it to do recommendations. This is exactly what StumbleUpon is doing as well. So they are adapting the search engine to their use case. Or you can do supporting. This moves away sort of from the human interaction, because what this customer is actually doing is processing data in real time, finding some threshold. So in case things escalate and they reach a certain threshold, then they actually have already some sort of diagnosis in place. So when the human intervenes, he already has some sort of diagnosis there, so he can figure out what's going on. Logging. There was this problem mentioned here today, right? A lot of companies nowadays have this problem. There is more and more machine-generated data that humans have to, make some sense of, and obviously the rate of growth keeps increasing. So Elasticsearch is becoming sort of a de facto solution there for the open source. Several popular projects are there: Logstash, Graylog2, or Kibana, which I'm actually going to demo to you guys in just a second. Or you can use Elasticsearch, again, just an example for doing pure analytics. We're not talking about text anymore here, we're talking about data. So as long as that data is relevant to you, as long as you want to decrypt it, you can do that. And this is a snapshot from a customer of ours that has billions of devices that keep streaming data, and they do analytics, again, in real time. So what you see here, again, these are graphs that are computed on the fly. There's nothing pre-computed there. So looking at big data, right, because this is a big data group, if you look at the architecture, at least from my perspective, you end up where most people have something like this, right? You have on the left-hand side various sources, so you can have some sort of event streaming where you have tons of data sort of coming in continuously, or you might do some sort of ETL, so you have chunks of data that come in batch into your system, right? And then you have this distributed unstructured store where you put everything. Now, potentially, as the data goes in, you do on-the-fly real-time processing, whether it's big or small, right? But once the data is in, you want to tap into it. You want to push it upstream to the consumers and this is mainly us, the humans. So you might use some sort of hot store, semi-structure, right, where you either put pre-computed data or you put the window of data that you want to analyze really fast. You might want to use some sort of big SQL solution that has this hybrid mixture of both sort of batch approach and real-time approach, or you might use a batch processing framework like Hadoop. Right? And this data is being pushed either to your analytics engine or framework or directly to your users. So the question would be, okay, so where would I place Elasticsearch? And this is the annoying answer. It depends. Elasticsearch is pretty flexible, so you can pretty much put it depending where you want, pretty much everywhere. You can use it as, actually my use cases, to do some sort of real-time string. So as the data goes in, you can actually put it there and look at it, make some sense out of it. Once the data is in your store, if you want to look at it, you could just load that window of data and look at it, or potentially just store the results there for later retrieval. Or you can also use it as a complement or as a supplement to your analytics engines, or since we mentioned Hadoop, to enhance your Hadoop infrastructure. There were talks here about raw Hadoop, Apache Crunch, cascading, Hive, Pig. We have, I'm glad to support because, well, that's what I work. We have first-class support with Hadoop. So that means the entire Hadoop ecosystem. You get native integration, so you can read and write to Elasticsearch, so you can run your queries, you can index data directly from Hive, from Pig. From cascading, we have support for Apache Crunch on a branch as well. So you can, very briefly end up with something like this. And this is just a quick graph that I showed up. It shows the entire duration of a job, a Hadoop job, and you can see there MapReduce, Pig, and Hive. The green bar adds in Elasticsearch. The gray bar is basically the raw job itself. The writing means you're storing just data in Hadoop, and then in the green bar you can see also if you add Elasticsearch in, the overhead is negligible. When things start to shine in is when you're looking at the reading and query. And this is a small data set. We're talking about 70,000 entries, around 100 megabytes on a local machine, so just for this purpose of the demonstration, but you can already see the performance difference. And obviously this means not just saving time, because it's not just something that runs faster, but imagine doing geolocation in Hadoop. Without something that is already implemented, without a search engine, you would have to rewrite geolocation yourself, and it's not fun. So, now is the part where I have to show you the money. So this is a UI that we have on top of Hadoop. It's called Kibana. There are plenty out there. It's open source, just like Elasticsearch. So you can download it, you can use it, you can hack it. It's written entirely in JavaScript, so there is no stateful component here. Everything here runs inside my browser. So what I have here is just a basic UI. You can see here I have in Elasticsearch I just put some logs, HTTP logs, the typical entries where you have the time when a request was made, from what IP, the time, the request, potentially the user agent, and also the error code or number of bytes that were returned. So this is just raw data that is being pushed in Elasticsearch. By default, Elasticsearch is going to look at the data and do automatic sort of discovery of the data. So let's see now sort of how search fits into this type of data. And again, everything here is JavaScript, and you're going to see how this interacts with the whole thing. Here we have what is called a time picker. In this case, because Kibana is focused on log, is going to assume the data is basically time series. So it assumes by default is looking at timestamps. So let's make things interesting. And again, Kibana now, as you probably saw, it's here says milestone 2. So let's hope it's not going to affect this demo too much. So we're going to just add a graph very quickly. What we're going to do, I mentioned this powerful analysis capabilities. We're going to do histograms. That's a fancy term for saying do an aggregation. So in this case, I have some raw data. What does that mean? I want to visualize it somehow. So we're going to do the basic one, which means counting. So I'm, look at this stream of data and do some counting so I can figure out at this particular point in time how much data did I receive. So we're just going to add, again, this histogram. Just put it here, 12 columns, so it's fairly wide. Browser, add, close. Okay, I get a nice graph. If I move around, I can see how the data, interacts with me. I can sort of look at the data. Potentially nothing interesting, but the thing is, all this JavaScript does is just create a request that actually gets sent to Elasticsearch, which computes the result and sends it back. And in fact, if you look here, you can see the actual query that sits behind the JavaScript here. Kibana is written in AngularJS, for those of you that are interested in JavaScript. And here you can actually see even the curl there. This is the command line where you can actually pass JSON to Elasticsearch. So what we do here is literally give you in a pretty print the actual JSON that you can send to Elasticsearch, and you get the results back, and then you get this graph. And you will see as I add new UIs or new blocks of data, pretty much everything has this what we call spy, so you can see the JSON behind it. And the nice thing about Kibana is all the things are integrated. So as you move along, for example, here I can, let's say I do 5 minutes, I do an auto refresh every 3 seconds, let's say. So I'm looking at the data, and now what happens is the data keeps moving. So here, again, because this is JavaScript inside my browser, every 3 seconds the browser is going to load the page, the JavaScript is going to send the HTTP request to Elasticsearch, is going to look at the data. In this case, the search means I'm looking at this segment of data. So I'm looking from this point on to the last 15 minutes, and every 3 seconds I'm advancing a bit, right? So then my window of data keeps moving, right? This is what search means for this particular type of data, right? In this case, time series. So you can see how the data keeps moving. All right, I can, again, zoom in, zoom out. So one thing that we can do here is, okay, I can visualize the data. Let's add some more context into it, right? So I can add, for example, a pie and say, you know what, give me the requests so I can figure out what type of requests were made. Okay, let's arrange this a bit. So I can put this to 9. Okay, so I have now here a pie that basically gets, again, created in real time. So I can, play with the data and see these graphs being changed. And again, if I look here, you can see the actual JSON command behind it. There is no magic, right? This is just the way that this data is being represented, but the whole streaming, the whole computation is being done by Elasticsearch. So if you look here at the facets, right, the aggregation, the fancy term for this, literally says, take a look at the data, apply a filter. So, don't load everything here. Just look at this particular data. Then as you filter it out, in this case, we're looking at the whole data, so there is no querying that we're actually doing. Just look at the request, take the data size of 10, split it by terms, and send it back. And that's what we have here, right? You can do things like this. I can take a look and figure out why I have here a bit of a spike, right? So I can see here that, okay, something fancy is going on, so potentially I can do, okay, I have, a couple of HTML pages, and this particular PHP, oh my God, barbecue sauce takes way too much memory. So I can look into that. There are tons of functionality that we can add. For example, we can, let me see, we can split it. Since we talked about search, what we can do is just add number of hits for a particular term, so you can actually see, again, let me just arrange this a bit. So now I'm looking at the entire query, okay, everything it's being hit here, but potentially I can do things like, okay, you know what, add PHP, add HTML, add GIF, okay, and then add the on search, and then bam. Suddenly I can figure out, within my load, let's bring this just just a second. Lines are better. So now I can see, okay, this is my load. This is the impact that each particular file has, and I can also do it here. And it all looks like magic. All I did was just use this JavaScript, but behind it, right, all this logic, all this computation, all this streaming of data or analytics, sorry, are being done in, if I could only see that I here. There we go. directly by the engine. This is just pure streaming. This is just data that is being searched, and because it's stateless, I can actually even load, for example, the dashboard itself. So we can do, what a lot of bosses like, which is a world map. So you can see what's going on. And again, if you look behind it, it's just JavaScript. This one says, find me look at the entries and do an aggregation by country. Now that I have the country, I just have to put it into a D3 map, and then suddenly, oops, I have a heat map that maps on top of the country. I can also have these graphs here by country, and if I do again, if you want to do the audio refresh, you can actually see that the data keeps coming in and the different countries are being analyzed. So this is just, eye candy on top of Elasticsearch. So that's in a nutshell the various capabilities. You can see, searching, dealing through data, getting analytics out of it, searching, zooming in, zooming out. For us, really, it's not so much about the technology, but rather about, enabling users to explore data, making some sense out of it. So that's it for me. I was trying to rush really quickly through this to make sure I have time for the demo and the questions. That's my Twitter ID, and now if you have any questions, I'm here for you. Hi.
What about if you try to bring in data that doesn't have a time source?
Can you repeat the question?
Yeah, so the question is, what happens when you try to bring in data that doesn't have a time source? So Kibana, for this particular case, is designed, it's a UI for logging. So the assumption is the data that you throw at it has logging in it. Elasticsearch is not a time series data store or search engine. This is just a use case where it's being used to look at time series. But as far as Elasticsearch cares, it can be both structured and unstructured data. So really it's up to you to define your data model to say, okay, this is relevant, this is this type of data. The engine doesn't really care. Yes?
Can you describe integration with Hadoop briefly and how you're positioned against the impending search product from Cloudera?
Okay. There are two questions there. I'm going to talk the one that I know most about, which is what I'm currently working. So what we do in the Elasticsearch integration with Hadoop is to, as I said, make it very easy for you to read and write data to Elasticsearch. So writing means, okay, you have data in HDFS and you want to index it in order to access it, which means you want to stream from HDFS or potentially Hive, Pig, Cascading, Apache Crunch to Elasticsearch. So we have an input-output format. So just as you write a job, rather than using a text input or file input format, you say Elasticsearch input format, and we do that automatically. For Hive, we offer external tables. So as far as you're concerned, Elasticsearch is just a table within Hive, so you can write to it or you can query it. We support it just the same, and similar with Pig. So for Pig, we have Elasticsearch storage, which means this is you use Avro or a sequence file. This is similar. You don't really feel any fraction, or at least that's what we're trying to do there. We have worked to support, especially for Pig and Hive, load operators or push down operators, which means when you do a count, for example, the native way of saying would be, okay, pull all the data, push it to Hadoop, and Hadoop does the counting for you. But we can do the counting automatically because we already have that. So it's about translating the operations to Elasticsearch. Now, one important thing here is that a lot of issues that have when you have, even the fastest store, when you put it into a distributed environment, the problem is you don't have one machine hitting it. You have a cluster of machines hitting it. So the nice thing about Elasticsearch and Hadoop is that they both scale. So Elasticsearch, when it writes data, it doesn't write to one node. It actually writes, depending on your setting, to multiple nodes. When you do a query, we don't query one node. We actually spread. We do parallel queries. So when you're looking at Hadoop, what we do in all the integration is when you run a query, we actually look at where your data resides. We actually figure out the number of shards that it can answer that. We do a split. So actually, when you do the query, you run it in parallel across the entire cluster and then send it back. So we actually map one-to-one to the tasks, the parallel tasks that get executed inside Hadoop to run against Elasticsearch. Because one I think here is Hadoop tends to be I/O bound, right? You have a lot of data going on, you have a lot of CPU and memory that is not being used. Elasticsearch is the opposite. So actually you can do a nice collocation because what we do inside the integration is when you run a query, we actually figure out the nodes, right? We spread, and then we feed that information back to Hadoop. So if you have data stored, because Elasticsearch can store the data internally, or you can store it in HDFS, if you collocate, basically, when you run a task or a query, we figure out the task, we figure out where the nodes are, so then Hadoop can actually use collocation, so the code actually resides where that, where the code in HDFS resides is the same place where the Elasticsearch query will happen. Yes. Yes. The question? Oh, sorry. Yes. I was looking at you.
Yeah. I saw Storm up there. Is there some sort of integration with Kafka, for example?
Storm. There was no Storm there, but we have. So we don't have any official integration with Storm. Yeah, here. Yes, real-time processing S4 and Storm. Yeah.
So is there some way you can feed something not? I'm not actually sure how it does the query over HDFS, but if you have some sort of data coming in, like logs or whatever.
Yeah.
So then you can also integrate it with just the general data stream, so it makes this data comes in that way.
Yeah. So we don't. Okay. So if I can synthesize the question and still, keep it close to the truth. In case of real data streams coming in, is there some sort of integration, for example, such as with Storm? Does that hit the ballpark?
Kafka, yeah.
Or Kafka, yeah. Storm is more of a computation engine. So Elasticsearch doesn't have any policies or rules regarding how the data is being fed in. It's really up to you. So you can, since Elasticsearch is real time, it means as the data comes in, we have to make it available. Now, if there is a lot of data coming in, depending on your settings, we can say, okay, you can wait for it, and this is where you have to basically make trades. You can either say, I want to have data consistent, which means I have to wait for the data to be in the cluster, and then I can enable it, I can serve it, or it can be asynchronous, where you say, as the data is being available, I can start answering questions for it, right? So this is a setting that you can define very dynamically based not on the entire data set, but actually on particular type of data, particular type of indices, depending on your cluster. So this applies, coming back to your question about Kafka. We don't have any integration out of the box supported by Elasticsearch. We have people in the community that use that. So they use Kafka as what it was designed for, to push data in from various sources, and then use that as a main bus to push data, for example, to Elasticsearch. Now, we're fairly flexible. That's the whole, I think, takeaway point here, is that we're not a replacement. We don't do this or do that. It's really up to you. We're very flexible. So you can use Elasticsearch to index data. You can use it to put data in and then do some part of the querying. We're not so abandoned here to saying this is what we are. We just want to rather focus on what we can do and let people figure out what they do.
Okay.
Yes.
I'm just conscious of time, so.
Okay. Sure.
Costin, thank you very much.
Thank you.
Great. I'll keep it brief. I'm a last-minute invitee to the party here, so I'll just dive into the high level and leave it at that. I'm representing a company named SkyTree. We're based in Silicon Valley. We're a startup. We have a product. It does machine learning. I have a colleague here, Nick. Please stand up. Nick Ball, standing right over there, is one of our data scientists. We're here in the UK because we're working with one of our customers locally, and we thought it would be nice to stop in and say hello. So good evening. Thanks for officially or unofficially having us here at your event, but here we are. What SkyTree focuses on is machine learning. Specifically, we like to characterize it as production-grade machine learning, and I'll explain what that means in just a second. I've seen R come up a lot in the conversation tonight, so just as a show of hands, how many of you would be people who use R probably regularly or consider yourself moderately strong or power users? How many folks fit that? That's quite a lot. That's great. And then how many of you have probably tried out R at school or at some sort of lab setting and at least tinkered with it? Probably quite a few. And some have never touched it at all, right? That's probably a collection of folks right there, Rebecca. So what we're going to talk about right now is something that's similar to that in terms of the types of computations. We think of machine learning as something which provides advanced analytic capability, predictive analytics. Things that on this chart here, you would say at the bottom in the very tiny print are machine learning methods, things that are called support vector machines and gradient boosted trees and so forth, random decision forests. Those are specific algorithms that people use. Above that are the things you do, the natural tasks that you actually do, like clustering. And why do you do clustering? Because maybe you're interested in doing market segmentation. And why do you do outlier detection? Because you want to detect fraud, or you want to predict an attack, a denial of service. So there's a variety of high-level use cases. And what SkyTree set out to do when we built the company was come up with a way to implement these high-performant machine learning methods, but to do so on quote-unquote big data. That is, data that far exceeds the capacity of a single machine or a single user that might be more familiar with using R or SAS on a desktop. Our objective is to bring machine learning to a very, very broad data set that might be across an entirely distributed clustered environment or a Hadoop environment. So in doing so, we looked at what do you currently do if you have big data and you want to run the most advanced algorithms. Well, you have a problem. For example, if you want to take a subset, you can then analyze on a smaller scale, but now you're obviously going to be losing outliers. You're going to be losing quality in the results. You could also just use a simpler method that doesn't require two-dimensional or three-dimensional non-parametric computations. That's great, but you're going to lose the benefit or the added value of a very high-performant computation. You can use simple parallelism, which is really you're running the same thing a bunch of times across a lot of nodes. Interesting, but again, doesn't bring you the depth and breadth of an advanced method. You can also just put it in the cloud. People believe they can just put a lot of data out there and magic will happen. So what we focused on is we drew from academia, and our real foundation as a company originates with a couple of colleagues that started out of Georgia Tech that were in what was called the FAST lab, and their thing was fast. How do you take something which would be an uncomputable problem and make it computable? So if you have 10,000 rows and you do an n-squared computation, there's a million computations. That's not so bad. If you have a million rows and you do an n-squared computation, that's 1 trillion computations. If you do an n-cubed, you don't ever compute the result. But there are clever ways and smart ways to program those kind of algorithms that enable you to reduce, and what we've done is take n-squared and n-cubed and reduce them to order n or order n log n. So in that regard, we're able to bring very, very complex computations down to a manageable compute cycle. The performance speaks for itself. When we do comparisons against R, against Weka, what we find is it's an unfair comparison because SkyTree is optimized and designed to run these kind of things like a nearest neighbor, a support vector machine, which again are very bloated type computations. If you just brute force them, you can copy them out of Wikipedia and program them, and people do, and that's good. But there are limits into what you can compute. So our business has been built around focusing on one of the things, speed. I'm always asked, how do we do this? And again, part of the answer is algorithms and drawing from the latest algorithms and utilizing what's available in the research to grab the best ideas and put them into computations. That leads to better machine learning. The second piece is this smart programming, really utilizing very efficient ways to do these complex higher order computations. And the third piece, taking advantage of parallelism in a way that actually doesn't give away some of the benefits of large data, basically, of giving up the big data. So a snapshot of who we are. Some of the guys on this name in particular, I focus on the gentleman on the technical advisory board. These are, in our view at least, I know I'm US-centric, but that's where I live. But these guys are rather the leading lights, if you will, in machine learning and distributed systems and parallelism and visualization and HPC. We bring them together along with our own talent. We're pretty proud of the kind of folks that we've been bringing on board. Lee Wilkinson is pretty legendary in the world of statistical analysis. He's one of our guys, along with Tim Marsden, who came out of Sun and Apple, and helping us to build product that both is algorithmically fast and as also technically well distributed and well programmed, so it runs well in a complex environment. So we just got funding. Yay! That means that we get to hire a lot of people, and we get to continue to build out our product. So we have two core products. SkyTree Advisor is more of a desktop general purpose stats engine. It's a free download. If you want to grab a copy, try it out. That's actually largely the work of Lee Wilkinson, and if you like what he's done, I think you'll be excited about that product. Free. The other one is not free. That's SkyTree Server. That is the machine learning engine that's designed for the large-scale data systems. That's what Nick's working on right now. In fact, with one of our customers doing the deployment there, and where we're seeing a lot of uptake and interest because if the problem is speed, if the problem is improving accuracy to yet a higher level, if the problem is doing it over a large distributed amount of data, we address those problems. So that's what we have. That's what we do. In keeping this quick and interesting, I'll just finish off by saying we are hiring. Check our careers page. You can download Advisor. I brought, if you guys are into machine learning, you might appreciate the joke. It's funny. So if you want to grab a t-shirt, please do. I got a few of them up here and a little stack of white papers. So come on by and have a chat. That's it.
Thank you. Someone must have a question for Paul. Daniel.
How do you
how do we compare what we do with Mahout? I did not put up the benchmark chart. I'll just give one benchmark number. So one of our customers, consumer electronics company, was building a recommender system. Naturally, they want to be able to recommend TV programs on a smart TV. They were doing some benchmarking on Mahout with 10 nodes, 4 million rows of data. It took 97 minutes to get a recommendation out, and we took 4 seconds. And that's because we would say that Mahout, although a good machine learning implementation for Hadoop, has not been optimized to take advantage of a lot of advantages that we do. So it's just a single data point. We've got more of those. If you want to ask me about them, that's great. Again, I would say the broad difference is that we exclusively only focus on speed. So, and we're not free, open source on that part of the product. So kind of the trade-off, you know, because I used to work at Red Hat. I respect and I love open source. I think it's a really great way to get started. But there are limitations to what's available in the open source community. I'm confident they will be overcome over time, but in the short term, there's an alternative. I'll leave it at that.
Yes.
Do your optimizations involve approximations, or are they literal instantiations of the original algorithms?
Fair question. We are always asked that question, and our CTO would probably, take out a knife right now because he really despises the concept that anyone would think that we would approximate. We don't, actually, no, to be perfectly honest. And I won't say this is how we do it. It's obviously IP. It's our own intellectual property and our own design. But for just a conceptual comparison, what we often will describe is the discrete Fourier transform and the fast Fourier transform, which is an incredibly sped up way to get an n log n speed up, but not to do an approximation on data and not to do an approximation on a result, but to get an exact result. So it's not what we do particularly, but just for those who are mathematically inclined and experienced with that particular comparison, that gives you a sense that there are smart ways to program an algorithm to still go fast without making it an approximation. Yeah.
Licensing, the price of the license is not an issue if you've got the business case.
That's correct.
I'm just curious, are we talking like 100,000 or a million or 10 million for like 10 million?
Yeah, prices are in the range of $50,000 to $100,000 for when people get started, and they go above that if you go into a large-scale deployment. So this very much is designed for the business scenarios where that kind of cost is justified by the payback because you're getting a considerable improvement in how you can reduce fraud, or because you're going to get a considerable improvement in how you do your segmentation because that's that valuable to you when you're marketing to 80 million people. Those are the questions we're generally answering. So. We have not architected it for a small startup, for example.
One more?
No more? Yes?
Yeah.
How do you help people get to the right algorithm or the right approach to solving their problem? Because
right. How do we get to, yeah. How do we get people to the right algorithm and the right approach? And it's a very good question. That's what Nick does, for example. And in fact, Nick should definitely come up here afterwards and answer more questions than I, because he could give you the more technical drill down. But the short answer is this. We are a software product. We're intending not to be we're not a consultancy. However, we recognize and understand that for everyone that gets started with SkyTree Server, we generally do what we will call a sort of an initial model development. So we'll help by reviewing data sources, by assessing the alternative methods that we have available, and then selecting one to go to work. We build a model collaboratively with the data scientists that are working at the company where we're helping. And at the end of the day, the model belongs to the customer. We don't keep models. That's not our IP. Our IP is in the algorithms down in the machine learning layer. And then the models run on top of SkyTree Server, if you will. And that's just our knowledge transfer that we do at the start of a project. So generally speaking, there always is this sort of a kickoff phase where we do some training, some model development, and then we have a support package, obviously.
All right.
Okay, that was great. Thanks a lot, everyone. Appreciate it.
I know everybody's dying to get a last drink. And there's many of you who have cheated. But before we finish, quick shootout. Has anyone anything to share with the community, whether that be you're hiring or you want to share some exciting news? I can start. I'm hiring. So if you're interested in real-time big data, come talk to me. Or there's a few other folks for our company, Akunu, in the back, who provided the nice banners on both sides. Anyone else? Yep, Jamil? You need to stand up, Jamil.
Things that Metric's also hiring, check our website for details, in particular if you're interested in big data ops.
Big data ops.
Will speak to me.
Anyone else? No? All right. A lot of people asked. Well, we're going to make it easier for you. You're going to go to bigdatalondon.org and we'll publish all the sites, all the slides. Give me just a bit of time. Hopefully we get them tomorrow. And that's it for tonight. So thank you very much for attending and looking forward to see you at the next meetup. It's not yet scheduled, but if you're interested in sponsoring, hosting, or speaking, please contact me. Thank you.